Alright, so we're back on the Conar vacuum tube voltmeter. It's model 211. And I did find a service manual, schematic for this. The service manual looks like it's a how to assemble the thing. And so this may have been a kit. If it was, the person who did the kit did a very neat job, because I didn't guess this was a kit. But anyway, I've got it warming up. I took care of the obvious. I took care of the electrolytic capacitor there. It originally had a 20 microfarad at 150 volts, and now it's a 33 at 160 volts, because that's what I had. And the 1.5 volt battery used primarily for ohms has been replaced. So we've changed only the blatantly obvious things that needed to be replaced. And now that that has happened, let's see where that gets us. So I should be on DC volts, and with no ground reference, apparently I am volts. So we're going to snap those together, and then we're going to zero our meter. I actually should probably spray a little bit of lubricant in that. That one's a little sloppy. Stand by, I'm going to do that right now. Okay, so anyway, after messing with this, I did bother to look up a little bit of these on these. Obviously, when my pod is turned all the way to the right, we're there, and we can go all the way past 0 to the left. So we're in, that should be what it does, and I should be able to find 0 easily there. And we have Mr. Carlson's lab did a big thing on vacuum tube voltmeters, and it was very, very in-depth. If you're going to watch a Mr. Carlson video, you do need to have an attention span, because it's always involved. So anyway, we've zeroed out our meter, and you can tell just by my fingers here I can make her jump. We're on the 3 volt scale, and I've got a 1.5 volt battery that I think checked out to be a little low at about 1.4. So one would think we would get all the way to 1.5, but we don't. Let's try negative DC just for fun. Yeah, it seems like it likes 1 volt. Now that might be, you know, under a load. This might be it's a pukey battery. I have a newer battery here. Let's see what it does with my newer battery. And again, this isn't a reference checked load, so I can't be a cajillion% sure. We got it set to negative volts, so I got to put the battery on backwards. And again, 1 volt. That's not correct. This should be 1.5 volts. If I go to the 12 volt scale, again, we're only showing about, and definitely not enough volts. Definitely not enough volts. We're showing, actually, on the 12 volt scale, we're showing 1 volt again. Not correct. Okay. How about ohms? Okay, for ohms we are supposed to bring that out to the line for infinity and set that to 0 approximately. Close enough for jazz. And crap, it's got to be zeroed, and then we have to zero it with the clip leads together. So open should be infinity, and then together, so I got to do these in the right order. Zero it over here, And then infinity, something like that, right? I think so. So I should see about 47 ohms. And I see about 50 ohms. Okay, so we're closer now that we've got a 1.5 volt battery in there. It seems to have helped. There's our 0, but our infinity. Is our infinity really supposed to be all the way to infinity, or is it just supposed to go just to the top of the scale? Maybe it's supposed to go just to the top of the scale. I do have the manual that I have to read, but I don't have an attention span. This should read 47 ohms. Just shy of 50 ohms. Okay, that's a little more reasonable. Let's snap this to the 10 scale on ohms, and of course we got to make sure it's all zeroed out again. Infinity. Okay, our 0 moved on us. Of course it did. Let's see what we get on the 10 scale. Still not there. Well, this is no correction. We are there. Not quite, but we're around there, because on the ohm scale it'd be multiplied by 10, and I've got, it's showing like 42 ohms, 42, 43 ohms, and we should see 47, which would be more properly read over here. That looks kind of like 47, so I think this thing probably just needs to be calibrated as opposed to having to be severely repaired. We have these trim pots up at the top. I'm sure they do something. That sounds really confident, doesn't it? I'm sure they do something. They do something. I know they do. Okay, so DC plus is neutral here. Let's just, for fun, and I'm not tremendously serious on getting this guts on accurate yet, but let's see. I should have 1.5 as my voltage here. Does this trim pot do anything? No. How about this one? Oh yeah, that one really does something. That one's dirty. Look at how that thing jumps around like a wild animal. I think that might be our problem. Let's spray a little schmoo in that. And then let's just twist the daylights out of it with our battery disconnected here. And let's look at what our voltage reading is now. Alright, let's see if we can set that to about... Good grief, is that jumpy. Noisy, noisy, staticky pot. It's like it's got a dead spot in the middle, doesn't it? There's 1.5, actually a little bit more, 1.6, which is typical of what I would expect out of this battery. Let's compare that to our other meter. Our other meter says this battery is 1.591. So I'm going to go with that meter being correct. I'm going to put this on. I've got 1.5. So this would be 1, let's see, this is 1.5, and that's 2. So we should be at about 1.6, right? I got to go a little bit more. This pot is jumpy. It's a noisy pot. That looks like 1.6 to me, because that would be 1.75. So we're looking at 1.6. Okay. So let's try a couple other voltage tests, and see how close to in range. Okay, so I've got my little bench power supply set to 10 volts according to my relatively new meter. And yes, I know my relatively new meter isn't the brand that you guys like, because everybody likes a different brand, and the fact that I have a cheap one is probably breaking your heart right now. So if this is on 10 volts DC, I should get full scale. We should go up to 10 DC, 10 volts. Helps if I don't short the connection out. So that's good. That's a proper 10 volts. Go up a little bit to 12. This meter says 12 volts. This pot inside of the adjustment inside of this power supply can be a little janky. So this is not luxury lab equipment. This is crap we bought at the surplus store. Okay, this is not Mr. Carlson's lab. This is Mr. V's pile of crap. And according to my new DMM, that is 11.99 volts. It says 12 on here and 11.99 there. So I'm feeling fairly good that our volts DC is okay now. Let's try one more. Since we're capable of more, let's go up to a 30 volt scale. And let's increase our voltage here to what would be, we'll say 25. That looks like 25 to me. .25 volts. And then we'll compare it to our young meter. And our young meter is complaining that I have it on the wrong scale. 24.9. 25.0. Okay, so DC volts on this has been set by fiddling around with this little pot. That's cool. Now let's fiddle around with the other pot and see what that does. I know, that's not the way you're supposed to do it. You're supposed to do this according to the laboratory procedure. Do I ever do anything like that? Well, our ohms appear to be real good, and our DC voltages appear to be real good. So I suppose I should next get an AC voltage supply and tweak a little bit more. I figured out what this one's for. This one I don't know what that does. That probably has to do with AC volts. Okay, so I looked a little bit more, got everything tweaked. Our AC voltage reads a little bit high, but we're talking by like 1 or 2 volts, not anything too major. I'd rather it tell me the voltage is a little high on AC than to shock the crap out of myself. But knowing the projects that I'm going to do, we're all working with DC anyway, and the DC voltage is on and the ohms are on. So I mean, we can consider this a working unit now, give it a spit and polish and send it on down the road, or keep it around here as a fun little heirloom. But you know, granted, it's cool to have a vacuum tube voltmeter. I don't really know that it's going to beat a Simpson 260, but I think it's cool, and I'm glad that it's not in the trash. Alright, thanks for watching.